Next example, we want to find the area bounded by the inner loop over limits on r equals 1 plus 2 cosine theta. So we are looking for the area of the region bounded by that inner loop. So we're going to be finding, so firstly we need to find the limit of integration. So we want to see where we're going to hit the origin. Then we'll go inside our inner loop, and then we hit the origin again. So to hit the origin, we need to look for a point when r equals to 0. So 0 equals to 1 plus 2 cosine theta. So negative 1 equals to 2 cosine theta. Cosine theta equals to negative 1/2. Cosine theta equals to negative 1/2. When theta equals to 2 pi over 3 and 4 pi over 3. Use your reference angles when cosine theta equals to 1/2 and you find your angles. Now, if we know the limit of integration between 2 pi over 3 and 4 pi over 3, we write in our formula for area in polar 1/2 r squared d theta. Write down what is our expression for r, 1 plus 2 cosine theta. So we're going to get 1/2 integral from 2 pi over 3 to 4 pi over 3. Square the sum. We're going to get 1 plus 4 cosine theta plus 4 cosine squared theta d theta. So we're going to 1/2. Antiderivative of 1 is theta. Antiderivative of cosine is sine. To find antiderivative of cosine squared, I will use cosine reduction formula. And cosine reduction formula will tell me that antiderivative of cosine squared theta equals to cosine theta sine theta over 2 plus theta over 2. Multiplied by 4. And we're doing it from 2 pi over 3 to 4 pi over 3. 1/2. Times 4 pi over 3 plus 4 sine of 4 pi over 3 plus 4 cosine of 4 pi over 3 sine of 4 pi over 3, plug in upper bound, over 2 plus 4 pi over 3 divided by 2 minus 1/2, substituting 2 pi over 3 sine of 2 pi over 3 sine of 2 pi over 3 divided by 2 plus 2 pi over 3 divided by 2. And we're doing and we will do calculations here. So final answer is going to be pi minus 3/2 root of 3. If I want to find the area of the region bounded by two polar curves r2 theta and r1 theta between theta equals to alpha and theta equals to beta, so I'm looking for this one, for area of this region. Then I'm going to look at it the following way. That's one we're looking for. So I'm going to look at it as big piece, the total piece, minus that small piece. So that's how we're going to obtain the area between two polar curves. because now we know how to calculate the first piece, and so we're going to get how to get the second piece. So area is going to be equal to area of bigger piece, 1/2 from alpha to beta, R2 squared theta d theta minus 1/2. Now to calculate this area, we use second function, R1 squared d theta. And that's how we're going to be calculating the area between curves, between two polar curves. And if you like, we can also 1/2 out and put that maybe as a common integral, alpha to beta, R2 squared theta minus R1 squared theta d theta. It's the same integral as our original one here. That's an idea to how we're going to be calculating the area between two polar curves. Let's do an example. So we want to find the area of a region which lies inside of r equals to 1 plus 2 cosine theta, limason 1 plus 2 cosine theta, it's a black one, and outside of circle of radius 2, it's a green one. So we are looking for this region. So using the symmetry, what we'll be doing is we'll actually be finding on the vertices above x-axis, and we're going to be calculating it, and to find the whole thing we'll multiply using the symmetry, we'll double it. So our calculations are going to be double 1/2 integral. Bigger curve is limason 1 plus 2 cosine theta squared minus smaller curve is circle 2 squared d theta. Limit of integration, we start when angle equals to 0, and we finish when we hit this point. To find where we hit this point, we set functions equal to each other. So limason equals to circle, so 2 cosine theta equals to 1, so cosine theta equals to 1/2, so theta equals to pi over 3. So upper limit will be pi over 3. So 2 and 1/2 cancels out, so we get integral 0 to pi over 3. Square of a sum, so we get 1 plus 4 cosine theta plus cosine squared theta minus 4 d theta. So we're going to get integral 0 to pi over 3, 4 cosine theta plus cosine squared theta minus 3, which equals to 2. Antiderivative cosine is sine. Cosine squared, we're going to be using cosine reduction formula. Cosine theta sine theta over 2 plus theta over 2 minus antiderivative 3 is 3 theta. From 0 to pi over 3. We're going to substitute. We're going to get 15 root 3 minus 2 pi over 6 as our final answer for this problem. We have a following problem. We want to find the area of a region bounded by one leaf of 4 leaf rows, 2 cosine of 2 theta. Let's firstly recall the graph of 4 leaf rows. So it starts on x-axis, then it goes around and around and around and around. So we need to find one leaf. So actually what we'll be doing is we'll calculate this piece. We'll calculate this piece because for this piece we'll know over a lower limit theta equals to 0. Because we're doing area and polar, we're going to be writing 1/2 r squared d theta. Yet to figure out what we're going to put on top. So So let's see, we're going to get, and because we decided to calculate only half of what we want to do, we're going to double it. So 2 times 1/2 is gone, so we're going to get the integral 0. Our function is 2 cosine of 2 theta d theta. Now to find the upper integral, that's when we're going to hit the origin again, so when r equals to 0. So we have 2 cosine of 2 theta equals to 0, so we have cosine of 2 theta equals to 0. So cosine of pi over 2 equals to 0. So in our case, n equals 2 theta, so 2 theta equals to pi over 2, so theta equals to pi over 4. So our limit, upper limit is going to be pi over 4. Get upper limit pi over 4. Don't forget to square it. So we have to 0 to pi over 4. Square it. So get 4 cosine squared 2 theta d theta. Do u substitution u equals 2 theta. Find du, find d theta. And also I will change the limit of integration, and I will write in terms of u equals to 0, u equals to pi over 2. And if you do substitution, we end up with extra 1/2 in front, so we're going to go ahead cosine squared u du. So we're going to get 4 times 1/2 is 2. Antiderivative of cosine squared is using cosine reduction formula. Cosine u sine u over 2 plus u over 2, and we're doing it from 0 to pi over 2 for u in terms of u. Because we changed the limit of integration, we're not going to be going back to theta, so we'll just plug in pi over 2 and 0 for u. Sine of pi over 2 is 1, cosine of pi over 2 is 0, so we get 0 plus pi over 2 minus sine of 0 is 0, so minus 0, minus 0. So final answer 2 times pi over 2 over 2, so final answer is pi over 2 for this problem.